Okay, so we're going to talk about experimental design now. Experimental design is the research design that controls for internal validity the best. So the best causal evidence that a change in the dependent variable was caused by the independent variable comes from an experimental design. So this has the highest internal validity. Okay. The classic experimental design has a pretest, a post-test, a control group, and experiment group. So the way that it's run is we have our sample, we've gone and created our sample, and then we randomly assign the people in our sample to two different groups, an experimental group and a control group. Then we want to measure the dependent variable of each group, which is our pretest. So let's say we're doing a study. We want to find out if cognitive behavioral therapy helps reduce anxiety. So the pretest would be an anxiety scale. Before our study started, after we randomly assigned them to groups, we'd give everybody an anxiety scale to determine where they are in the anxiety level, both our experimental group and our control group. Then we would do the intervention, and only the experimental group would get the intervention. So we'd do cognitive behavioral therapy for, let's say, 6 weeks with the experimental group. Now, the control group has the cognitive behavioral therapy withheld from them. And in social work, this is unethical. So what usually happens in research is the control group would be put on a waiting list, and then after the study, after 6 weeks, then they would get their therapy. So after the experimental group is done with the therapy, then we want to measure the dependent variable in both groups again. That's our post-test. So we'll go ahead and give everybody the anxiety scale and see where they are. Okay, and then we look at our results. So our hypothesis is supported if the improvement in anxiety in the experimental group is greater than the improvement in anxiety for the control group. All right, that makes sense. Our intervention was successful if the people in the experimental group had better results, more improvement than the control group. The next slide shows us a diagram of the basic experimental design. And on the left, you'll see there's a column for experimental group, and on the right, there's a column for control group. And you'll see that both columns, we measure the dependent variable, and we want to compare those. They should be similar. The people should be similar on the anxiety scale. Then in the experimental group column, we gave them the intervention. The group on the right, the control group, got nothing. Then the final box is measure the dependent variable again for both of them. We want to compare that, and they should be, we're hoping they're different, right? If our intervention was successful, they will be different. Now underneath that, there's some notation that you'll frequently see in a journal article. The R's represent the two different groups, and the O1s, those are the pretest, X is the intervention, and the O2s are the post-test. So now when you read an article and you see that, you'll know that what they're saying is they did a basic experimental design. Okay, there's another kind of experimental design that's called a post-test only control group design. And we use this if we think that pre-testing and post-testing will give us a biased result. So remember in our last PowerPoint we talked about the threats to internal validity, and one of them was testing. So if you think testing is going to be a threat, then you can use this design. It's also used when pre-testing isn't practical. So again, we do random selection to remove any significant differences in the groups. So we randomly select people to group 1 and group 2. So on the bottom you'll see that notation again. The R's are the different groups. There's no O1, so nobody got a pretest. There's an X, so the first group got the intervention, And then there's just an O because we're only doing one test after. So we're doing a post-test only. And then we're looking to see if there's a significant difference in the anxiety level between the two groups, if we're testing for anxiety. Another thing that is used in experimental design is matching. This is used to improve chances that groups are comparable. So we take our sample and we match up participants based on similarity in one or more variables that are important. And then one member of each group, one member of the control group and one member of the experimental group, are assigned to be a pair, and they're similar on that characteristic, whatever that variable is. Okay, so it might be that they're similar in gender, or they're similar in age, or it might be that they have similar anxiety levels. So whatever the variables are we're looking at, we'll match them up, and that improves our chances that we're starting off with comparable groups. So if you read an article and they're talking about matching, that's what that is. Okay, then there's quasi-experimental design. And a quasi-experimental design is used when control groups or random assignment isn't feasible, but it still has pretty good internal validity. So one experimental design, quasi-experimental design, would be, let's say, I read an article about a social work program in North Dakota, and they have an online program, and they were testing how well it was successful in their human behavior and social environment class. Oh, actually, I can't use that example because that's in your activity today. So I just gave that away. Okay, let's do another example. Let's say I want to look at how well an intervention works in youth who live in group homes. And I have two group homes that I want to look at, and one of the group homes is going to use the intervention and one of the group homes is not. So we can still do most of the experimental design components. We have two groups, one's a control and one's an experimental group. They'll both get a pretest. Then one of them, the experimental group, will get the intervention, and they can both get a post-test. What's missing is the random assignment. I couldn't say, okay, you guys go live here in this group home, and you guys go live here in this group home. They were already living there. So I wasn't able to use the random assignment there. So that's what makes it quasi-experimental. So if I'm unable to have a control group or unable to randomly assign them to the groups, they still have good internal validity, not as high as a classic experimental design. There's another type of experimental design called simple time series design, and this uses multiple pretests. And this can be used when you don't have a control group. So let's say I only have one group. I don't have a control group. Nobody's on the wait list. I only have the people who have come for the cognitive behavioral therapy. So what I'll do is before the session starts, I will give them 5 pretests. Let's say the pretests are maybe a week apart. Let's say we know the session won't start for 5 weeks, so I give them 5 anxiety scales. Every week they come in, take the anxiety scale. And then the therapy starts. And they have the therapy for 6 weeks. Then, for the 5 weeks after therapy, I have them come in again once a week and take the anxiety scale again. So these multiple pre- and post-tests are controlling for other threats to internal validity because we don't have a control group to compare it to. So if we look in the first 5 weeks and we see that anxiety has gone down, and then we do our intervention, we can't necessarily say that our intervention caused anxiety to go down because it was already going down, right? Or if we look and we see that after the results of our intervention, anxiety goes up, we might say, gee, there might be something else that's also causing some influence instead of just our treatment. So we'll have lower internal validity if we see changes there, right? If it isn't what we expected. So the simple time series is also an experimental design. It is not as, it does not have as high of internal validity as the classic experimental design, but it still has good internal validity.